Hey everybody, Miss Hester here, and I wanted to give you a quick tutorial on one-step equations. Now this will not cover every single scenario you'll ever see, but it gives you an idea of the basics. We're going to start with finding out what x equals giving addition. So let's say I've got an x plus 7 and it's going to equal negative 8. Now the whole purpose about algebra is to find out what the x equals. So we want to get this x by itself. What I need to do in order to get x by itself is perform the opposite operation. So my operation here is a plus 7, and the opposite of plus 7 would be a minus 7. And if you recall in the fairness rule, what I do to one side, I must do to the other. So if I minus 7 here, I have to minus 7 here. Now the minus and the plus 7 on the left side will cancel out, leaving the x all alone. And then on the right side, I have a negative 8 and a negative 7. They don't cancel, in fact they combine. 8 negatives and 7 negatives will give me a negative 15. Alright, that was one example. Another example is sometimes the variable is on the opposite end of the equation. For example, we've got a 10 equals x minus negative 2. So instead of the x being on the left side, sometimes it's on the right side. No problem. But what we need to take care of first is this minus a negative here. And if we work with our LCO, leave it, change it, opposite, that minus minus turns into a change it, opposite, turns into a plus. And it's a really good idea to rewrite these kind of questions. 10 equals x plus 2. That way you don't get mixed up in all the signs and you can solve it quickly. So again, we want to get the x by itself, so I have to do the opposite of a plus 2. Well, that would be a minus 2. So if I do minus 2 on one side, I have to do it on the other to keep it equal and fair and balanced. This plus and minus 2 will cancel out, leaving x all alone on the right side. Now on the left side of the equals, we have 10 minus 2. That equals 8. So in this situation, 8 equals x, or x equals 8. Okay, I want to show you one more on the adding, subtracting, if I could fit it down at the bottom. Draw a little line here. Okay, let's say I've got a variable, but it's not x anymore. You can use any letter. For example, g. It's the same thing as an x, it's just now a g. If I take, of course there's a buzzer. If I take g minus 5 equals negative 14, it's just like the x. But now I want to get the g all by itself. So I do the opposite operation. Instead of doing a minus 5, the opposite would be a plus 5. What I do to one side, I must do to the other. Plus 5. Now this positive and negative 5 will cancel, and I have g, all by itself. And it's going to equal 14 negatives and 5 positives. Those will cancel each other out. 5 positives cancel out 5 negatives, and I've got negatives left over. If I subtract the 2, I'll see I have negative 9. So in this situation, g is equal to negative 9. Alright, so that's your adding and subtracting. Next I want to show you a multiplication and division. Alright, get a nice fresh sheet of paper here. Alright, multiplying. Alright, example is negative 5 times x, when they're next to each other that means times, equals 50. So negative 5 times something equals 50. In order to find out what that is, I have to get the x all by itself again. Now if I'm multiplying x times negative 5, the opposite operation would be not to multiply but to divide. So I'm going to divide both sides by negative 5. Negative divided by negative is a positive, and 5 divided by 5 is 1, giving me 1x all by itself. Then on the right side, positive 50 divided by negative 5 equals negative 10. You've got to be aware of your integer rules when you're working with positives and negatives. Okay, one more example for multiplying. Let's say I've got 44 on the left side, and on the right side I've got a variable, 4 times x. Just because the variable is now on the right side instead of the left, it doesn't matter. I still want to get the x by itself. So what's bothering the x is this times 4. To get rid of a times 4, I do the opposite. I divide by 4. What I do to one side, I must do to the other. So 4 divided by 4 is 1, leaving me with 1x over here. And it's going to equal 44 divided by 4, which is 11. Remember, you always want a positive x, not a negative x up here. So be aware of that. All right, last examples. Woohoo! We're going to do some division. Okay, let's say I have half of x equals 7. Doesn't that look like multiplying? But don't forget that 1/2 of x is the same exact thing as x divided by 2 equals 7. Okay, once again, I want to get this x by itself, so I have to get rid of a divided by 2. I perform the opposite operation. The opposite of dividing by 2 would be to times 2. What I do to the left side, I must do to the right. And a divide by 2 and a times 2 will cancel out, leaving the x all by itself, and 7 times 2 is 14. So is that true? Half of 14 is 7? Or 14 divided by 2 is 7? Yes, that is true. Okay, the last thing I'm going to show you is a little bit advanced. And you should be able to grasp it, I think. So, advanced. Wow. All right, goofy teacher. Okay, let's say I've got 3/5 x equals 9. Well, I still want to get the x by itself, and I want 1x. So I need to use something that's going to cancel out the 3/5. If I multiply 3/5 by its reciprocal, 5/3, the 5 and the 5 can cross-reduce, and the 3 and the 3 can cross-reduce, leaving me with 1/1, which equals 1, giving me 1x by itself. Now, if I times this side by 5/3, I also have to do the same thing to the right side, 5/3. Now we're into our multiplying rules. Multiplying fractions ain't no problem. It's the tops times the tops and the bottom times the bottom. Wait, 9 doesn't have a bottom, so we have to put a 9/1. 9 divided by 1, it still equals 9, but now I could use it as a fraction to multiply across. Okay. If you like, you can cross-reduce the 3 and the 9 to give you a 1. 3 divided by 3 is 1. 9 divided by 3 is 3. Now I'm reduced. 3 times 5, 15. 1 times 1, 1. So my x on the left is going to equal 15 divided by 1 on the right, which is 15. X equals 15. Now, would this reciprocal have worked up here at the top? Let's find out. If I take 1/2 and flip it, I get 2/1. Multiplying those two, 2 divided by 2 is 1 whole. So that's 1 whole x. Now I've got to do the 7 times the 2/1 times 2/1. So 7/1 times 2/1 is equal to 14/1, which equals 14 divided by 1, 14. Does this match this? Yes, it does. All right, so that was a little bit of advanced stuff down here. You'll see that a bit in 7th grade. But I hope this tutorial video helps. Have a great evening.